Next example, in trig substitution, I have the integral 1 over x and then times the radical 9x squared plus 1. This is the radical sum of squares. So we know where to, or how to label the hypotenuse, right? If it's the sum of squares, the hypotenuse is the radical. 9x squared plus 1 is the radical. Variable vertical, so what's getting squared is 3x. And the horizontal is the last piece of the puzzle. That's just 1 because 1 squared is 1. All right. So we're going to choose the function that does not involve the radical, that's tangent. So we know that tangent of theta is 3x. I don't want 3x. I want 1/3. And then the differential, 1/3, derivative of tangent. What's the derivative of tangent? Secant squared. So that piece is squared away. Now, choose the function that does involve the radical. If this is tangent, that stinking better be secant, and sure enough, secant is adjacent over hypotenuse. So that's the square root of 9x squared plus 1. And the substitution now is exact. So what do we have here? X in the denominator. What is x? X is, these are denominator values, so this is 1/3 tangent theta in the denominator. X is in the denominator. All right. What else do we have here? The radical. The radical is secant theta, that's in the denominator. So we have a radical in denominator. The radical is secant theta, so there's a secant theta in the denominator because the radical is secant theta. And then the last piece we have here is the differential, dx. dx is, and this is in the numerator, we have 1/3 secant squared theta d theta. All right, let's see if we can simplify this a little bit and see what we have left out of all this mess. Let's see, that 1/3 cancels with that 1/3. This secant cancels with one of those secants. All right. And we have a tangent left, so let's go. So what do we have? We have a secant in the numerator, d theta. We have tangent in the denominator. This is not going to work well because of this fraction, so I think what we're going to do is convert everything in sight to sines and cosines. All God's children get converted to sines and cosines. So what is secant? Secant is 1 over cosine. And what is tangent? Tangent is sine over cosine. And so what do we have here? We have sine theta, cosine squared theta. All right? So what does that give us? Well, we can rewrite that as sine theta times cosine theta. That's going to be to the -2. And this is an ordinary garden variety U substitution. You have a function raised to a power. Let U equal that function. So du, derivative of cosine is negative sine. And we don't want the negative, so negative du is equal to sine theta d theta, which is exactly what we wanted it to be, right? So I'm going to see what we have out of this mess. Sine theta is negative du, and we have cosine squared, cosine to the -2. Well, cosine is u, right? And negative du is sine, right? So we should be all squared away. And so what do we have? This is the power rule. I want u to add 1 to the exponent. So that's u to the -1. And what was u to begin with? U was cosine theta. All right. So plus c rather. And then what is cosine? Cosine, let's go back to the triangle. We don't have cosine here, but we do have cosine in the triangle. Cosine is adjacent over hypotenuse. So this is, notice, 1 over, it's a complex fraction. 1 over adjacent over hypotenuse, 9x squared plus 1, plus c. If you want to leave it this way, that's fine. It's probably not asking too much to simplify this complex fraction. Multiply by the reciprocal. It's not too hard to see. That's what we have out of that mess. So that's the process. You need to keep your wits about you, but what we inherited was something that required an ordinary U substitution.